Assalamualaikum. My name is Alif. My person number is 2, and I'd like to show you about our presentation, and our matter is measurement and scaling, non-comparative scaling technique. And I'd like to introduce our team.
My name is Anissa Nurinta Fitri. My present number is 8.
My name is Nadia Birana Putri and I'm number 33.
My name is Elia Ernandila. My present number is 13.
Non-comparative scaling techniques. Non-comparative scaling techniques in which stimulus object is scaled independently of the other objects in the stimulus set. Respondents using a non-comparative scale employ whatever rating standard seems appropriate to them. They do not compare the object being rated either to another object or to some specified standard, such as your ideal brand. They evaluate only one object at a time, and for this reason, non-comparative scales are often referred to as monadic scale. Non-comparative techniques consist of continuous and itemized rating scales, which are described in the following sections. Continuous rating scale. In continuous rating scale, also referred to as a graphic rating scale, respondents rate the objects by placing a mark at the appropriate position on a line that runs from one extreme of the criterion variable to the other. Thus, the respondents are not restricted to selecting from marks previously set by the researchers. The form of the continuous scale may vary considerably. For example, the line may be vertical or horizontal scale points in the form of numbers, or brief description may be provided. And if provided, the scale points may be few or many. 3 versions of continuous rating scale are illustrated. The advantage of continuous scales is that they are easy to construct. However, scoring can be cumbersome and unreliable unless it's computerized. Itemized rating scale. In itemized rating scale, the respondents are provided with a scale that has a number of brief descriptions associated with each category. The categories are ordered in terms of scale position, and the respondents are required to select specified category that best describes the object being rated. The commonly used itemized rating scales are the Likert, the semantic differential, and staple scale. The Likert scale. Named after its developer Francis Likert, the Likert scale is a widely used rating scale that requires the respondents to indicate the degree of agreement or disagreement with each of a series of statements about the stimulus object. Typically, each scale item has 5 response categories ranging from strongly disagree to strongly agree. The advantage of using the scales is it's easy to construct, administered, and to understand. However, the disadvantage of using the scale is it's more time consuming. Semantic differential scale. The semantic differential is a 7-point rating scale with endpoints associated with bipolar labels that have semantic meaning. In a typical application, respondents rate objects on a number of itemized 7-point rating scales bounded at each end by one of 2 bipolar adjectives such as cold and warm. Take note that the negative adjective or phrase sometimes appears at the left side of the scale and sometimes on the right. This controls the tendency of some respondents, particularly those with very positive or very negative attitudes, to mark the right or left-hand sides without reading the labels. Individual items on a semantic differential scale may be scored on either a -3 or a +3 or a 1 to 7 scale. The advantage of using this scale is that this scale is versatile, but the disadvantage of using this scale is it's difficult to construct bipolar adjective. The staple scale. The staple scale, named after its developer Jan Stapel, is a unipolar rating scale with 10 categories numbered from -5 to 5 without a neutral point or 0. This scale is usually presented vertically. Respondents are asked to indicate how accurately or inaccurately each term described by the object, selecting an appropriate numerical response category. The higher the number, the more accurately the term describes the object. Take note that the data obtained using a staple scale can be analyzed in the same way as semantic differential data. The advantages of using this scale is it's easy to construct and administer over telephone. But the disadvantage of using this scale is it's confusing and difficult to apply. Non-comparative scaling techniques. Non-comparative scaling techniques in which stimulus object is scaled independently of the other objects in the stimulus set. Respondents using a non-comparative scale employ whatever rating standard seems appropriate to them. They do not compare the object being rated either to another object or to some specified standard, such as your ideal brand. They evaluate only one object at a time, and for this reason, non-comparative scales are often referred to as monadic scale. Non-comparative techniques consist of continuous and itemized rating scales, which are described in the following sections.
Multi-item scale. A multi-item scale consists of several items, where items are a single question or statement to evaluate. The like semantic differential and staple scales presented earlier to measure attitude towards search are examples of multi-item rating scales that require considerable technical expertise. A construction is a specific type of a concept that exists at a higher level of abstraction than everyday conceptions, such as a brand loyalty, product involvement, attitude satisfaction, and so on. And the next slide is scale evaluation. Multi-scale must be evaluated for accuracy and application, alternative forms of reliability, and internal consistency reliability. Validity can be assessed by checking the validity of the content. And the next slide is measurement accuracy. Measurement is a number that reflects the characteristic of an object. A measurement is not the true value of an interesting characteristic, but rather the observation. Okay, next slide is reliability. Reliability refers to the extent to which a scale produces consistent result if repeated measurements are taken. Reliability can be defined as the extent to which steps are free from random errors. And the next, there is validity. The validity of a scale can be defined as the extent to which the difference in observed scale scores reflects the real difference between objects on the characteristic measure, rather the systematic of random errors. And the next slide is relationship between reliability and validity. The relationship between reliability and validity can be understood in terms of the actual score model. If a measurement is truly valid, it can also be relied upon. And the next slide is generalizability. Refers to the extent to which one can be generalized from observation made to the universe of generalization, to the sets of all measurement conditions that investigator wish to generalize to is a universe of generalization. Slide is choosing a scaling technique. In addition to the theoretical consideration and evaluation of reliability and validity, certain practical factors must be considered in choosing a scaling technique for particular marketing research problem. And the next slide is mathematically derived scales. All the scaling techniques discussed in this chapter require respondents to evaluate directly the various characteristics of stimulus object. In contrast, mathematical scaling techniques allow researchers to conclude respondent evaluation of the characteristic of stimulus project. And the next slide is international marketing research. In designing the scale or format of responses, the level of education or literacy of the respondent must be taken into account. One approach is to develop a pan-cultural scale or free from cultural bias. Slide is private sampling. Structural sampling is done by taking simple random samples from each predetermined population strata in stratified random sampling. The population is divided into several groups called strata. And the next slide is sampling cluster. Cluster sample is taking some zero randomly popular ball, then taking all or part of elements from each selected group to be sampled. And the next slide is non-probability sampling, non-random sampling, which was developed to address the difficulties that arise in applying probability sampling techniques, especially to eliminate cause and problem in sampling frames.
Ethical and market research. In this part, it has been explained, the researcher has the ethical responsibility to use scale that has a reasonable reliability, validity, and generalizability. The findings generated by scale that are unreliable, invalid, or not generalizable to target population are questionable at best and raise serious ethical issues. Consider the scale descriptor. The descriptor used to frame a scale that can be chosen to bias result in desired direction, for example, to generate a positive view of client's brand or negative view of competitor brand. To project the client's brand favorably, respondents are asked to indicate their opinion of the brand and several attributes using 7-point scale and scored by descriptor extremely poor to good. That is an example of descriptor that table. The point 1 from point 7 to good. We can show this table. Yeah. Thus, how important it is to use balanced scales with comparable scale, which negative and positive. When this guideline is violated, responses are biased and should be interpreted accordingly. The researcher has responsibility to both the client and respondent to ensure the applicability and usefulness of the scale. Similarly, like client, companies have a responsibility to treat their customer and general public in ethical manner. The following example proposes appropriate scale of evaluating the conduct to direct marketers. There is two types of sampling. There is non-probability and probability sampling. Probability sampling is probability sampling, or every element in population has some opportunity to become a sample because we choose our sample in random ways. Sampling has two types. The first type is sample probability sampling, and the second type is systematic probability sampling. In simple probability sampling, when your population is small and limited, it can be used and solved easily. But when your population is big and wide, it's hard to use. Systematic sample. This type of sample can be used when you want to pick a sample in systematic way, but still in randomness. When using this type, you need find the first point. It can be found between k and first element. The first element need to be picked in same interval. Example: you need 5% to choose in some company, but in this and in that company have 100 employees, and the interval is 10 and first point is 3. So the employees that you choose is the employee have third number, 13 number, 23rd number, 33rd number, and 43rd number.
Next is stratified sampling. Stratified sampling is done by taking simple random samples from each predetermined population strata. In stratified random sampling, the population is divided into several groups called strata. Each stratum has relatively homogeneous elements, consequently between strata become heterogeneous. Next, sampling cluster. Cluster sample is a random collection of several groups from the population, then takes all or parts of elements from each selected group to be sampled. Next, non-probability sampling. Non-probability sampling was developed to address the difficulties that arise in applying probability sampling techniques, especially to eliminate costs and problems in sampling frames. Next, convenience sampling. Convenience sampling takes samples based on element availability and ease of obtaining them. In other words, the sample was chosen because it was in the right place and time. Judgment sampling. Judgment sampling is basically a form of convenience sampling when viewed from the ways of taking the sample. Next, quota sampling. This sampling technique usually uses data from population related to demographics like population such as geographical location, age, gender, education, and income. And snowball sampling. Snowball sampling is one form of judgment sampling that is very appropriate to use if the population is small and very specific. The sampling is by chain. Distribution sampling. If a random sample is drawn from a specific population and is repeated with the same sample size, the statistical values obtained are random variables, which means they have an opportunity distribution, that is the distribution sampling. Next is sampling distribution of the sample mean. If a sample of size n is taken from a population of size n, then the expected value and standard deviation of the average sampling distribution are equals to population standard deviation divided by square root of sample and then multiplied by square root of population minus sample divided by population minus 1. If n is large enough compared to n or for an unlimited population, applies standard deviation of the average sampling equals to population standard deviation divided by square root of sample. If n is large empirically is greater than 30, then the central line argument applies the average probability distribution will follow the normal distribution. Sampling distribution of the sample proportion. Suppose that in an n-sized population there are e events of x, then the proportion parameter e is p equals to x per n. If we take a sample of size n from the population, the statistical proportion will follow the binomial distribution. Standard deviation of the proportional sampling distribution equals to square root of p in parentheses 1 minus p divided by sample and then multiplied square root of population minus sample divided by population minus 1. If n is large and n is large enough than n, then the sampling distribution P can be approximated by the normal distribution, namely by standard deviation of the proportional equals to square root of P in parentheses 1 minus P divided by sample.